Today we are at task number 5, scan types TCP connect scans. To understand TCP connect scans -st, it's important that you're comfortable with the TCP three-way handshake. We'll go there in a second. If this term is new to you, then completing introductory networking before continuing would be advisable. We've done that. As a brief recap, the three-way handshake consists of 3 stages. First, the connecting terminal, our attacking machine in this instance, sends a TCP request to the target server with the SYN flag set. The server then acknowledges this packet with a TCP response containing the SYN flag as well as the ACK flag. Finally, our terminal completes the handshake by sending a TCP request with an acknowledgement flag set. Here we see exactly that. So we are requesting to TryHackMe the attack box. We initialize this by the SYN flag. The attack box server goes with a SYN acknowledgement back to us, and we go back to the attack box TryHackMe server with an acknowledgement. Here we can see it in Wireshark. Source and destination, this is us to the destination. The protocol is TCP, and here we can see SYN, ACK, and acknowledgement, right? The 3 flags requested. This is one of the fundamental principles of TCP/IP networking, but how does it relate to Nmap? Well, as the name suggests, the TCP connect scan works by performing the three-way handshake with each target port in turn. In other words, Nmap tries to connect to each specified TCP port and determines whether the service is open by the response it receives. For example, if a port is closed, we see the RFC 9293 states that if the connection does not exist, which means that it's closed, then a reset is sent in a response to any incoming segments except another reset. A SYN segment that does not match an existing connection is rejected by this means. In other words, if Nmap sends a TCP request with a SYN flag set to a closed port, the target server will respond with a TCP packet with the RST reset flag. By this response, Nmap can establish that the port is closed. Here in this diagram you can see this. We request to the target a synchronization, but if the port that we request is closed, we send the target sends a reset flag. If, however, the request is sent to an open port, the target will respond with a TCP packet with the SYN ACK flag set. Nmap then marks this port as being open and completes the handshake by sending back a TCP packet with ACK set. This is all well and good, however, there is a third possibility. What if the port is open but hidden behind a firewall? Many firewalls are configured to simply drop incoming packets. Nmap sends a TCP SYN request and receives nothing back. This indicates that the port is being protected by a firewall and thus the port is considered to be filtered. That said, it is very easy to configure a firewall to respond with a reset TCP packet. For example, if IP tables for Linux, a simple version of the command would be as follows. And here we can see we just mark the IP table, the TCP over the port that we want. If we reject the request, it will respond with a reset TCP flag. This can make it extremely difficult, if not impossible, to get an accurate reading of the targets. Answer the questions below. Which RFC defines the appropriate behavior for the TCP protocol? We have it open right over here, 9293. But we have to place also the RFC 9293. If a port is closed, which flag should the server send back to indicate this? RST. Awesome.